And the question that we have before us is, how can we make a bone graft model of this? Okay, in here you have this, let me just put the nice and red pen in here so that we can see. We recognize this is an I element in here because of the weight, right? This is also an I element over here, and you have fluid in between. Now, if you put pressure on this, if you put pressure on this, um, you have the, sorry, if you put pressure on this, you transform that into one on the other side. But because there's a difference in area, the force gets has a mechanical advantage. So what I would do is I would just write a one junction here for the flow over here, and I say, you know, the velocity of this is going to be why don't we just write it a 1 also like this, and then we have a 1 for this. So this would be the velocity, let's call it v sub 1. This, let's call it v sub 2. And this, let's call it the velocity of this flow, this would be v sub 3. All right. Then we put the elements that are attached to these velocities. And obviously we have an input, a source of effort with force F1. You have the inertia in here, I, which would be with value, let's say mass M1, like that. On the other side, you have this, which would be an I element with value M sub 2. Okay. And you see there between the this and this, although they are not asking us to consider the um, inertia or so, but we could do the inertia and resistance of this. And here will be an I element, and of course an R element over here. Between these two, we have a transformer, right? So this would be TF, and this TF would go over here like this. And from here to this, TF. So what's happening is this in here on this side is, this is not a velocity but Q is a flow. This one, instead of B, let's put it Q. And then this would be the bone graft model. In this case, what we can do to make it a little more clear of what we did, because this turns out that this is red, so it can't do it as nice as we want it. So let's keep that in there, and I'm going to redraw it. I'm not going to change it, but just redraw it nicely. Here is a 1 with the Q on the over there, and then we have in here, we're going to put it this way, the inertia element with the value of Okay, and then the R element over here. Okay, so let's just do it perfectly here. I don't like the eye the way it looks in there, so I'm just gonna correct it. And so you see now this becomes a little better because now you have a TF in here, and this would do this. And then you had the other one in here, which was with f sub 2. See, so now we have the complete model here. If you consider that this fluid, let's say, is air, and it requires the some consideration of that compressibility, um, then we would modify the model. But as it is, this would be the bone graft model that I would use. But if it turns out that we want to consider that, we would come in here and maybe take off this lining here, and then allow for the compressibility of that by putting a 0, because by now there would be a difference in the flows, and this would become a C element. See here, like that.
So either one of those are correct?
Yeah. With C is with compressibility. Without the C, it means like oil or water, whatever it's in there, is incompressible. Okay, so this way you can have the bone graft model of the system here.
So that would only apply if it was a gas.
Okay.